problem by completing the square before we jump into quadratic formula. Here we have 6x squared plus 5x minus 6 equals 0. Notice that the a value is 6. So that means that I need to divide everything through by 6 on both sides. That gives me 1x squared plus 5 over 6 times x minus 1 equals 0. Next, we need to move the constant to the right. And then we need to take half of 5/6. So what's half of 5/6? 5/12. And I need to square it and add it to both sides. So 25 over 144. Now I know some of your teachers would just stop here and add that to both sides. That's fine too. I just prefer to go all the way out. Now the left side should factor into x plus what? Whatever half of 5/6 was, so 5/12. Great. Quantity squared. And that needs to equal 169 over 144. Aren't you glad you can use a calculator?
Just add 144.
It's a 25, yeah. Did y'all know that's a trick to adding 1 to anything? If you want to add 1 to any fraction, you just add the top and bottom and keep the bottom. Well, you don't look as impressed as I was the first time I heard that trick. We'll move on. Take the square root of both sides. And that gives us x plus 5 over 12 is equal to plus or minus. The square root of 169 is what?
13.
13. And the square root of 144 is 12. So that gives us x equals negative 5 over 12 plus or minus 13 over 12. And the nice thing about this is the square root disappeared. So that means that we're not going to have all that trouble of, oh, how do I write the answer? We can actually combine these. Negative 5 plus 13 is negative 5 plus 13. 8 over 12, which reduces to
2/3.
8 over 12. And the other one is negative 18 over 12.
Which is 3/3.
Okay, so if we keep going, 8 over 12 reduces to 2/3, right? And negative 18 over 12 reduces to negative 3/2. And those would be really easy to type into above a sign. The fourth and final method for solving quadratic equations is the quadratic formula. This is my favorite because it can be used on everything. And it's numerical, not algebraic. You know, it ignores all the variables, turns it into numbers, and you can get an answer. I like that. The quadratic formula states that as long as the quadratic equation is equal to 0, and a, b, and c are the coefficients of the square term, the linear term, and the constant, respectively, the following formula will solve for x. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. Let's look at our first example with that. Let's use the quadratic formula to solve x squared minus 5x plus 3 equals 0. So first off, is it equal to 0? Yes. Then I need to identify a, b, and c. We have to be really careful and make sure it's in the proper order. A should be what's in front of x squared, b should be what's in front of x, and c should be the constant. So in this case, a equals, b equals, and c equals positive 3. So we're just going to plug into the formula. X equals opposite b plus or minus square root of b squared. Now be really careful. When you square a negative, what do you get? A positive 25. So if you write down negative 5 squared, make sure you put the negative 5 in parentheses. Minus 4ac. All over 2 times a. Now at this point, what I recommend is that you keep the 5 and the plus or minus, and you change the bottom to just 2, and you keep the square root. And then calculate what's underneath the square root. So just right now, go ahead and calculate what this equals. Is it 13? Yes? What is that number called? Whatever you get when you calculate b squared minus 4ac, it has a special name. Discriminant. The discriminant. That's the number that can kind of tell you whether you're going to have two real solutions, two rational solutions, two irrational, two imaginary, and all of that. We don't focus too much on that, but it is nice to be able to identify it. If I say what's the discriminant, you would tell me that it's 13. Can I go any further? Will anything simplify? Now it just becomes an issue of which one of the ways do I type it into not CalcChat, that's for the calculus class. WebAssign is for you guys. Which way do I type it into WebAssign? Oh, let's see. Well, the nice way would be 5 plus the square root of 13 over 2, and 5 minus the square root of 13 over 2. Now on a quiz or test, you could just stop here. So there's one way to type it in. Another way to type it in is 5 halves plus the square root of 13 over 2, and 5 halves minus the square root of 13 over 2. And then the final way you could type this in would be to factor what out to the front? 1/2. And then you could type 5 plus the square root of 13, comma, 1/2 multiplied by 5 minus the square root of 13. I'm desperately hoping that is not what WebAssign wants, but it probably is since it's the one we like the least. We'll know tomorrow. Example 8. Now let's use the quadratic formula to solve 2x squared plus 8x minus 7 equals 0. The good news is it's already equal to 0, and it's already in the right order. Squares, linear terms, constants. So all we have to do is start plugging into the formula. We know that a is 2, b is positive 8, and c is negative 7. So we have x equals opposite of b, which in this case is negative 8, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So that gives us negative 8 plus or minus the square root of our discriminant, all over 4. Has anyone calculated a discriminant yet?
120.
120. Okay? Now the square root of 120 should simplify. Does anybody know what it simplifies into? 2 square roots of 30, yeah. Because that's the same as 4 times 30. And then the square root of 4 is 2, and the square root of 30 doesn't simplify any further. So that's negative 8 plus or minus 2 square roots of 30 all over 4. Now what's wrong? We can simplify all 3 of the coefficients here. The 8, the 2, and the 4. Remember that you don't mess with what's under the square root, just the outer numbers. But if you simplify 2 of them, you have to simplify all 3 of them. It's an all for one for all kind of simplification there. So that reduces down to negative 4 plus or minus 1 square root of 30 all over what? 2. Which is a beautiful answer, but probably not how you're going to be allowed to type it in, unfortunately. You'll just kind of have to play around with it. Or we'll come back once we've all had a chance to go home and kind of look at it. We'll come back and talk about it on Wednesday. So don't be in any hurry. You know, have some time to work on these. So let's make sure we get them right.
So we can print the homework off.
Yes, you can print the homework off, which is what I recommend. Okay, so I just checked WebAssign, and here's how you're going to have to type this in. 1/2 negative 4 plus the square root of 30, comma, 1/2 negative 4 minus the square root of 30. And that's only going to be an issue when you have it all over 2 or all over 5, when it's a fraction. Otherwise, it won't be that bad. So I think there are only 2 of them that are going to give you trouble in the homework. I'm glad we took a minute to look at that. Okay, here's our final example of the day. This goes back to rational equations. So you're probably wondering what it's doing in this section. Well, once we multiply through by the least common denominator, it turns out to be a quadratic equation, and we have to work it from there. So let's look at 1 over x minus 1 plus 3 over x plus 1 equals 2. What are the 2 restrictions?
X can equal 1 or negative 1.
X cannot be 1 or negative 1. If I get either one of those, I have to throw it out as an extraneous solution. Then, what is my least common denominator? X minus 1 times x plus 1. So I need to multiply all 3 of those terms through by x minus 1, x plus 1. Simplify and see what I have left over. Okay, so now I've multiplied through by the least common denominator. The x minus 1 simplified here, leaving me with 1 times x plus 1. For the next fraction, x plus 1 cancels, leaving me with positive 3 multiplied by x minus 1. And on the right side, nothing cancels. So I have a 2, an x minus 1, and an x plus 1 that has to be distributed. So if I just sort of walk through and clean up the left side, I have x plus 1 plus 3x minus 3 equals, does it matter what order I multiply these over here? It doesn't. And I suggest going ahead and multiplying x minus 1 and x plus 1. What do those become?
X squared.
Is that okay with you guys? Then I can go ahead and, the difference of 2 squares, and then I can go ahead and just distribute the 2 and get 2x squared minus 2. The left side still needs to be cleaned up a little bit, so we have 4x minus 2 equals 2x squared minus 2. So you can see that it is a quadratic equation. And to me, the best way to start a quadratic equation is just get it equal to 0. Let's see what happens. So since I have a positive 2x squared on the right, I'm going to move everything to the right. So I'm going to subtract 4x from both sides. And I'm going to add 2 to both sides. Now when I do that, I get 0 on the left and 2x squared minus 4x on the right, because the negative 2 and the positive 2 cancel to 0. So I don't have any constants left. What's the easiest way to solve 2x squared minus 4x equals 0? Factoring. Yeah, we can just take out the GCF, right? What is the GCF? 2x. And I'm left with 2x onto x minus 2. If I separate those and solve for each, I have 2x equals 0, so one of the x's is, and the other is positive 2. Are either of those restricted? Then they both should be the answer. Of course, we could store and check to make sure we haven't made a careless error.